Thanks. I never get used to that button.
Mm.
Okay. Uh, on the first lecture test, no, I don't have my schedule in front of me. Some of you do. Does it happen to be on the 20th or 20? No, usually I put it close to my birthday. Not trying to tell you when that is, but I think
It looks like September 30th for the
yeah,
first lecture. The
that's
first
good.
practicum
Yeah,
is the 14th.
right. That's when I would normally put it. I put the first one in fall, right around my birthday. I do it because I don't like myself and I get your results, and that's fine. But then people always want to argue this question or that question. So I try to refine the test year after year so that it blocks out the need for those questions to even be asked. But they always are. So test days are, what's the word? Uh, anxious days for most people. Okay? They are actually more anxious for me than most of you. I'm sure some of you have testitis, uh, very anxious, but I get anxious too. Not if it's for you or what, but I do until the test gets rolling. Once the test is rolling and underway, everything calms down. I used to study in college. I remember studying for chemistry class, and it was the first chemistry class I had taken at college, and I studied all night. I mean, I studied until I could hardly stay awake, and then I took no-dose, Tyrann. We had those pills, and they're just maybe uh, caffeine and niacin or niacinamide, and that would keep you awake, but not very sharp. I went to class in the lecture hall at the science lecture hall at UCI to take the test with 400 other people. That's how big the classes were. And the school only had a population of 1,500 because it was the first year. So almost half the school was taking that class. And we all sat down to take the test. But before I got to sit down, some of my friends looked at me and go, "What the hell? What the what's the matter with you?" And I said, "What do you mean, what's the matter with me? I'm just tired. I've been up all night long. I've been studying, you know?" And they said, "You take Tyrann?" And I said, I took a bunch of Tyrann. Okay. And they said, "Well, you can't see yourself." I was wearing a white shirt and my skin was beet red, shiny beet red. That's because niacinamide heats up the body. Scuba divers use it. Okay. To get into their wetsuits and to stay warm if it's going to be cold. Oh, okay. Anyway, who cares if I'm beat red or not? I'm going to take this test. Sat down, got my slide rule out. Now, I know some of you don't even know what a slide rule is. Maybe you've seen it, seen one, but I bet you haven't used one. First thing we were taught is how to use a slide rule. Horrible little gadget. I had my own, made of beautiful bamboo, and I used the slide rule, waited for the test. We all have to put our test face down and then go. And go meant to me, apparently, go to sleep. I fell asleep almost immediately at the first question because I'd been up all night. The Tyrann had worn off. I woke up somewhere where the rest of the students had advanced to halfway through the test. I lost my anxiety for a while, but when I woke up, boy, then I was anxious. How many of you get anxious before a test? Yeah, I can see you. Well, it doesn't help And it doesn't help for me to tell you to calm down. You just gotta learn to get through it, I suppose. You can do TM, if you know what, do you use the word TM anymore? Transcendental meditation, or just meditation?
Is that the one where you watch like a video and then you just like lay down and then listen to the video?
Oh, that's modern age stuff that you would do. We did it without video, and you usually have somebody teach it to you, and they talk you through it. And had it taught to me by an actual psychiatrist, then a medical doctor, and then a behavioral scientist. They all have slightly different ways. Really does work. Really does work. But I must be self-defeating because I don't use it much. Okay, now getting back to your question, which is a good one. I hope I set your mind at ease as to what's going to be on the first practice. All of these bone structures, name the bone, name the structure of the bone, such as the mastoid process of the temporal bone. And it's all multiple choice. On the other hand, the lecture test is going to cover the lecture material from last week, 2 lectures, this week, 2 lectures. The lectures are on the short side at the beginning here. They will lengthen. And I don't mean that in a bad way at all. All that lecture material, I try to prime you for it and see that you know it by asking you to take a quiz, practice quiz. Practice quiz have questions in it that are identical in nature to those that are going to be on the test itself. If you don't take the practice quiz, I wonder, now why would the person not take the practice quiz? It can't hurt them. It can only help them. I don't grade it. It's for their benefit. If they don't do well, then that tells them what they need to study at least, and that they need to study. They can also take it again. I've got it set so you can take the test 20 times. I could put infinite, but nobody needs infinite on those. And do it until you've got it correct. And don't just memorize the answers. That doesn't do any good. You got to understand. So those that you miss, you go to the book and take a quick look. So on the lecture test 1 on the 30th, there will be material from those lectures. Those lectures are also in print. Okay, you noticed, of course, as I go through the lecture, I go paragraph by paragraph. I read some of the paragraphs to you to keep them the same. Most I paraphrase, okay? And that's the material. You have that available to you to study all of the time. Okay? But on the first lecture exam, you will also have just had the bone practicum 1. And I am going to include some questions that weren't really covered anywhere exactly. About 6 questions is normal. 6 questions on the bones will be on lecture exam 1. So now I'm telling you the composition of lecture exam 1. And I'll do that for every test that we come to. Sometimes I will send you an email that refers to that and outlines what's going to be on any test. What are the 6 questions that I might ask on exam 1 that come from the bones? Different. How many cervical vertebrae are there? They go from C1, which is the atlas, then the axis, 3, 4, 5, 6. Vertebral prominence is 7. The answer is 7. How many frontal bones do you have? Say it for me. Don't let me start worrying now. How many frontal bones?
One.
Just one, right. How many temporal bones?
Two.
Two. Okay. There'll be about 6 questions on how many of this type of bone or that type of bone are there. That's the only deviation from the fact that all the rest of the test comes from the lecture material. Okay.
This is
Yeah.
the one for September 30th, right?
Yes, exactly. Okay, now I mentioned to you that sometimes in the course, I email to you instructions or outlines of what to study. Sometimes the class seems to know it anyway, but they get it from me anyway. Sometimes the class is asking me in personal email a question that I think that's a good question, and I wish I had everybody like right now in front of me. But because I don't, I can't answer it for everybody until Tuesday or Thursday coming up. Well, when I get one like that, I may respond in email, not just to the person that asked it, but to everybody. Okay, and I just want to be sure we're all on the same page. I can't do that unless you read your emails. I spent half of yesterday, the morning anyway, redesigning an address book. 1 or 2 people told me they're not getting emails. Well, how could they even email me or respond to me? They were responding to my personal email. Okay, when they had asked me a question, I wrote back, they used that address, and it was fine. But when I was sending out the mass mailing to all the people in the class, a few people weren't getting it. And I couldn't figure that out for the world until I looked really closely. I composed a letter that I didn't intend to send and did not. But I wanted to see all of the addresses in there. And damn it, some of the address had a quote mark in front of the @ symbol. And I don't know where that's coming from. I don't do that. Thunderbird, Mozilla Thunderbird is the program I use, and it's never done that before, but it was doing it now. So I had to redo the entire address book. And then I sent you an email again yesterday, and I've heard back from 22 of you. Where are the rest of them? There's 13 missing, and I need them back. Otherwise, I won't know that you're getting my emails. Okay, so go to that email when you can. I'll try to remind you at the end here. Go to that email and just reply to it. Most people say, got it, and then I can relax that everybody's getting it. Otherwise, you can expect a personal email from me. I'll have to do it the hard way. Okay, make it easy on me if you got it. But if you didn't get it, you can't find it, I'll need to know that. Okay. Somebody sent me something in the inbox. Why can't we use the inbox? Horrible thing. Horrible, horrible, horrible thing. The inbox means I get a notice in my regular email that so-and-so has sent me something. Doesn't tell me what. Says if I want to reply, I can do it right here and now. And I've tried a million times and you cannot reply. You have to go into Canvas, leave whatever you're doing, and find the inbox, find the message, and reply from the message, which you can never sort or do anything good with. So I don't like the inbox. Especially don't send me anything in the inbox. Don't even use it in our class. Instead, if you've got an outline to submit it then from your email, and put it as an attachment. That'd be great, great. Okay, now as far as the next practicum, which would be P2, it's going to be all lab. But I don't want to go any farther than that. Let's way in the future. Let's deal with the present. Let's get that high score on P1. Okay, anything else? Those are good. Okay, so at some time today, look for that email. I think it says email glitch in bio 11. Okay, and I tell you that I think I fixed it, and I'll know I have if you just send that back to me. Okay.
Charlie, for that, I was able to see the original email only after people replied, so I didn't get the original email.
Wait a second. I'm looking to see who was that?
Brittany?
Oh, Brittany. Didn't I write you back on that?
Oh, I don't think I got it.
Yeah.
I can double check though.
Okay, what happened is the other students got it, okay, and they replied to me, but somebody hit reply to all. And when they hit reply to all, it sent it back to you, okay, and they were able to get through. I checked your email at that time, and I think I had to make an adjustment on it, but take a look. We're having a lot of trouble, you and I, it seems. So take a look and get back to me later today, okay? I don't want to take up everybody's time. Anybody else with a problem with it? Okay. Yeah, it was just crazy to find that little symbol inserted in there, and only for some people. It doesn't make sense, but we'll need to just take care of it and go on now. Okay, let's look at chapter 6 and finish off what you need to do if you're outlining it. I left off, I believe, at spongy bone, which is just before that figure 6-9. Okay, so you would read the little bit on spongy bone, and then it would have a check your understanding in my book. We don't do those. We don't outline those. You may definitely want to do it, however, but we don't outline it. Bone development and growth. Okay, I don't worry about the learning outcomes, so turn the page. And yes to the term osteogenesis. You find that. Okay, we start reading, we read through that chapter. Intramembranous ossification, endochondral ossification. Figure 611 is very important. Okay. It has a lot of the drawing that we went over in our lecture material. Figure 611. Okay. Always pay special attention to any label in the drawings that are also labeled in the lecture notes. Okay, and then under endochondral ossification, bottom of the page, then you move over and you go through the steps. 1, 2, 3, 4, yes. 5, yes. The anatomy of the epiphyseal plate. No, anatomy of the epiphyseal plate. Welcome to read it. Clinical application? No. Postnatal growth? No. And move on to bone remodeling. Draw a line above that, and you can write stop. That's the end of the chapter, as far as an outline is concerned. Bone remodeling is interesting, very interesting. I have no doubt that half of you at least will read it anyway, but it won't be a portion of this class. Now we'll move on to chapter 9. Here it is. In my book, chapter 9 is at roughly page 208, 209, probably a little bit different, 1 or 2 pages for you. Classification of joints, very important, very important. Fibrous joints, the sutures that are immovable and also therefore synarthrotic. Next page, syndesmosis, gomphosis, cartilaginous joints, synchondrosis, symphysis. They're going through the types of joints in a slightly different way than we did. They're saying the same thing. They are just have rearranged the order somewhat. I think that's fair. I think that even helps. Then skip to synovial joint, continue. The general structure of a synovial joint, synovial fluid, ligaments, reinforcing ligaments. To the next page, nerves and vessels, no, you know. When we get to that paragraph, keep just pass it by, and one after that until you pick it up again at articular disc. Yes. Bursae and tendon sheath. Yes. Movements allowed by synovial joints. Yes. Under angular movements, the most important are flexion and extension. Use the pictures to guide you through that. On the next page of text, after flexion and extension, we have abduction and adduction, extremely important to us throughout the course. Circumduction, rotation, and at special movements, draw a line and stop for the remainder of the chapter. Well, there's a lot more in the chapter, and it begins to look like a reference work, especially when you get to table 9.3. And essentially, it is a reference work. It's a lot of material that you are going to learn when we study the muscles, but it's beyond our meager starting point at this time. Okay, so when I said put a line, put the word stop, I meant yes, stop for outlining the chapter. Okay. Chapter 2 is going to be assigned.
Charlie,
Yes.
we stopped till rotation. Rotation.
Yes. Yes.
Okay. Special movements. No, right?
No. I put the line above special movements.
Okay. Thank you.
Chapter 2 is going to be the chapter assigned next week for anybody who wants to get a start. And unfortunately or fortunately, that's one that you have done before. You've had it. You couldn't be in this class without having a year of biology, and I can't imagine a year of biology without the cell. So that chapter will be complete. In other words, you'll outline the entire chapter 2. Okay, well, that's when we get to that. Okay.
Charlie,
Yep.
where will we stop in chapters as far as covering like the practicum 1 and lecture 1?
When you come to the chapter, you have outlined it, submitted the outline.
Right.
I'm not terribly critical unless I find that the outline is so skimpy it doesn't do you any good, then I tell you. Or if I feel that the outline has been just copied, cut and pasted from some other document, then I really tell you. Okay.
Okay.
But as far as the lecture and lab tests, you won't need the book. You have converted the book to your outline.
Right.
And
Okay.
so what you should do is be confident in your outline, okay, and true to it, and just review your outline before any test, okay? And then, of course, you need also to do the online Canvas material that I've posted and gone over with you, and will review with you ahead of time
Okay.
for lecture and lab.
So for the 14th test, will the material stop at the end of next week? Like it'll cover up through next week's material?
It definitely will cover the 2 next week. Yes, it will, because on Thursday you have a 5-day gap before, I think it's 5, before you actually have to take the test.
Okay.
I would not give you brand new material for a
Okay.
test on a Tuesday
Right.
and expect you to take the test on a Thursday.
Okay.
Then I would. But yes, it's going to cover today and the 2 lectures next week.
Okay. Thank you.
We could almost call this discussion.
Charlie,
Yes.
there will be any practice quiz this week or not?
Yes.
Because I cannot see it in this week.
No, it's not there now.
Okay.
I have them in place. I have to flick the button and turn them on, you know, when I want. I had a practice quiz I was looking at for you for last night, but you're not ready yet. You're not
Okay.
ready. So I will either consider you ready after today and put it up tomorrow. Usually Friday is my day, or the latest would be right after the lecture on Tuesday, if that quiz includes something from Tuesday. Probably what I will do is go over that quiz and modify it so that it doesn't include anything from Tuesday, because I would like you to have a practice quiz tomorrow.
Okay, thank you.
And please do not be afraid of the practice quizzes. And if you think they're going to take up all of your time, the average time spent on one round of the practice quiz that you already had was like 4 minutes. Okay, so. Okay, what else? Anything? Well, that's the closest we've come to getting on a roll. Okay. Okay, are you with me with in today's material in week 2?
Yes.
Okay.
Yeah.
Scared me a bit because it stalled for about 5 seconds. Don't know what the problem is, but here we are. We're ready to go. Okay. Okay. 2 lectures today, and they're both very short. Okay. We'll start with levels of organization. You'll see how short this one is. Okay. You've had this before. I know you have. There's some, I almost call it remedial material or review material that we're asked to go through to be sure everybody, vocabulary wise, is on the same page. So we do it and suck it in, and then we go on, and then we get to the muscles and all the organs of the body. Levels of organization.
Charlie, I have a question.
Yes.
The ones that said for today's date with the lab in the module, will those also be on the test on the 9th? Or is it the 9th or sorry, the 14th?
Practicum was on the 14th. Let me go back and see what we're talking about here. Okay. For the lab test, you're going to have this topic here. These are the names and locations of all the figures that you have to know. Okay, this actually is a guide showing you where those figures are, but it names everything that you have to know. Okay. And that's for the skull. Then when we went through the skull itself on screen, you need to know everything in this spot. Come down to the next day, and we have bones and structures again. It's part 2. Okay. And you need to know everything that is in there. Okay. Now, everything that is asked for in part 2 and part 1, they're both listed up here in bones and locations in the textbook. Okay. And so this is a guide, and this is the material here and here. They'll both be there. What we did on Tuesday in lab will be there. What we're going to follow it up with on Tuesday will be there. The first one is the guide again, the locations where you'd find them as figure such and such in the book. And then the bones and structures, you need to look at that. Look at the video if you want, or just go through the material at your own speed, or do both. And that'll be there. And so will this be there. The upper appendicular skeleton, this is the guide. These are the bones, ending with lab. They'll be there. Next week, the bones and structures of the lower appendicular skeleton. This is the guide. And it doesn't have the word lab. No, it does. Okay. This will be there. And then the actual bones will be there. This is next week on Tuesday, on the 2nd. On the 4th, it's a free day. By free, I mean no new material. It doesn't mean it's free and there's nothing to do. There's a lot of studying to do, a lot of remembering to do, and I'll have the review session going for you at that time, so that you would then take the exam. Following that, you have one free day. Okay. Week 2, still where we are. This is the upper appendicular skeleton. Here's what I mean by the guide. Okay. It names everything that you need to know. So you got a lot of new terms being thrown at you again today. But you know what? I think you're going to find that these are easier. And I think you're going to find that memorization gets easier and easier. Doesn't use too many figures in the text. All these last ones are figure 8-6, 8-4, 8-3, 1 and 2.
I have a question.
Sure.
On the practicum on the 14th, will it have similar diagrams on the test to our lecture when labeling?
Just hang on a second. You know, you're not supposed to, you would not be able to see this if you were at home, because this is not turned on. Okay. And I'm just realizing something. Yeah, I'm glad you saw it here, and I can explain it here. Those are the wrong dates there. Okay, you have the right dates. The test is on the 10th. Okay, but these dates are not correct, and this material is not available to you yet. This is module 3. Okay, module 3 or week 3, same thing. I usually post it like Sunday night, okay? Because I don't want you to shortchange the module that you're on. If I just go right ahead and give you another one, it could even be looked at as overload. Now, Jessica, what was your question?
I just had a question on the diagrams. So the diagrams found in the lecture, you mentioned in our on Tuesday's lecture that there might be labeling from the pictures. Are the pictures going to be the same as the Canvas material on the test?
Are you talking about, you're talking about the lab practicum?
Mm-hmm.
Okay, lab practicum is strictly on bones. Okay, we know that. The pictures, no, the pictures can come and be my pictures, the ones that I have used with you. They will never be drawings out of a book. Don't use drawings. It'll be actual bones, but the bones can come from anywhere. When you grab a femur out of a bone box, there's 20 bone boxes in the room. It doesn't matter which one you take. They all look the same. And I can just see somebody, you know, nodding their head like you, that, well, he says they're all the same, but I bet I'm going to have trouble with that. No, you're not. No, you're not going to have trouble with it. Okay. If you know what the bone looks like, you know the marking that's on it, and you've learned it from any bone that is decent. Okay. Then you're going to know it for the test.
Thank you.
Okay. Okay. Levels of organization. Let's get back to that. Okay, let's reduce this. Okay, levels of organization just talks about how we go from the simplest form of life to the most complex forms of life. Cells are considered the simplest form of life. And you know this from your biology class. I don't care when you took it, 7th grade, 8th grade, 9th grade, college, you had it. I know you had it. Cells are generally considered to be the smallest living entities. Sometimes a single cell is a living entity, and it's the entire organism as well, like a paramecium or amoeba. Okay? All cells come from pre-existing cells. That wasn't always the case. Life had to spring from something. It didn't spring from nothing. At least that's our dogma. And all organisms are composed of one or more cells. We'll be looking at the cell later today. The 4 types of tissues. Well, tissues are composed of similar cells that perform a common function. If we name some of these, this will make sense. There are only 4 basic types of cell, tissues, although when we get to histology, we'll learn 20 or 30 different, more minor types of tissues. But for now, we consider that there are 4 types of tissues composed of cells. And the first is epithelial tissue. Epithelial tissue covers or lines. So your outer skin, the part of your skin that you can touch, okay, that's an epithelial tissue. It's a specific type of epithelial tissue, and the name for which we'll be learning later on. Where else do we have epithelial tissue? Covers or lines. The inside lining of the stomach is an epithelial tissue. The inside lining of a blood vessel is epithelial tissue. It covers or lines. We also have nervous tissue. We have muscle tissue. And we have connective tissue. Connecting one item with another, or interconnecting items of the same type. Connective tissue include bone. So that's the one we're studying right now. Blood, chemical connection of the body through blood. Adipose or fat is connective tissue. Cartilage we've talked about. And there are plenty of others of connective tissues. In fact, there are more types of connective tissues than any of the other 3. There's a little diagram here that's not terribly helpful, but not bad. Here's muscle tissue. You can see the striations in this skeletal muscle. Nervous tissue. These are meant to be the cell body of neurons. Epithelial tissue like your skin, making a solid barrier. Sometimes the barrier is penetrable, however, and in your blood, you can press plasma out of the vessel if there's enough force and into the lymphatic system. The connective tissue, on the other hand, this could be spongy bone. I don't know what they're trying to draw here. Okay. But it interconnects all of the pieces. An organ, it's composed of tissues that together perform a common function or functions. The word common doesn't mean commonplace. The word common means the same function. So if we get tissues that come together to perform a function, or sometimes more than one function, then we have an organ. If I ask for examples of organs in any class, it's the one I get the greatest number of answers for. Everybody comes up with the stomach. Everybody will come up with the pancreas, the heart. A lot of people will skip over the skin, not realizing the skin is the largest organ of the body. The liver and the brain are organs. Can you name me one more or two more organs?
Your lungs?
Yep, lungs is the one I was thinking of.
Kidney?
Kidneys, yes. Okay, of the 6 that I have here that I've chosen, 2 of them utilize the greatest number of calories, your energy, throughout the day and night. Which 2 do you think they are that are just constantly at work?
Your brain?
Heart. Brain and
Stomach and heart. Brain and heart.
Okay, let's take the nomination of brain and say yes, but you haven't got the other one. It's not the heart.
The stomach?
No,
Your pancreas?
no,
No, your liver.
liver has to work all the time. Okay, so it's the last 2, the liver and the brain, do the greatest amount of work in over the period of a day. Oh, I said so, didn't I, in the next sentence? Did anybody read it? When you have organs that work together, they're called an organ system. Now, the organ system includes the nervous system, muscular system. The muscular system has many muscles associated with it. The integumentary system. The digestive system has the stomach, the colon, the small intestine. The pancreas is part of the digestive system as well. So you have multiple organs working together in these organ systems. The organ systems that are listed here were the ones I told you don't need to outline in chapter 1, the ones with the black background picture, okay? Because we're going to be covering all of these separately. And then finally, we have the organism. Okay. All of them coming together, the organ systems, we have the organism.
Charlie,
Mhm.
I have a question. We don't need to know the function for each organ system.
You don't need to know that now.
Okay.
You will need to know it later on. Okay.
Okay.
So if I want you to know, and I do eventually want you to know the function of all of these, I want you to take them apart. I want you to name all the parts that are in it, how it works.
Mhm.
That's coming. But right now, we're still at the introductory stage. Okay.
Okay.
And,
Thank you.
okay.
So not even for the first test.
The first test is only naming bones and structures.
Got it.
And it's all photographs.
Mm,
There are no drawings at all. Just photographs.
okay.
Okay.
Thank you.
Now that reminds me to remind you, you have to have decent Wi-Fi.
Mm.
If you try to take the test, the practicum, on a cell phone, you'll die. You just won't be able to do it. You should also have a Chrome browser. People who have trouble never have a Chrome browser. Okay. People who have the Chrome browser never seem to have trouble. I don't know why one browser is different from the other or how they optimize for the Chrome browser. I just know that they're telling you the truth. Okay. If you don't have good Wi-Fi in your house, or everybody's got games on or something at 2 o'clock in the afternoon, if everything that runs on Wi-Fi is running in your house, you may not be able to take the test. So think about it beforehand. You want good Wi-Fi. If you don't have it, what would you do? Go to a library. They usually have it. Go to a friend's house that doesn't mind you coming in, if that's the case. Even position yourself close to the router may help. How are you going to know if you have good enough Wi-Fi to take the test? The test is going to load up 100 pictures immediately. Sometimes with people with slower Wi-Fi, they have to wait and the picture sort of comes down like a blind. And once it does hit the bottom, it's fully loaded, and then the others are all fully loading, and it gets done. But that's still sort of scary to see it do it that way. It should come on all at once. Well, just go to your internet before the test, anytime. Turn it on, of course, and get the browser going. And I hope it's a Chrome browser. They're free, easy to install. And then put in the search box, speed test. And Spokio or one of the other ones will be happy to do a speed test for you. Okay. And it needs to come out above 100. Okay. I know 150 is adequate. Now Cox Cable tells me I need more because they need more money. Yeah, jeez. I spend enough with them each month. And I don't need more than 150 because that's what I'm using. And everything loads up just instantly. Okay. But try it. And if you get very low download speed, like 60 or something like that, you're looking at trouble for the test. Okay. Give it a try sometime soon. And you can let me know. I can't come over and fix it, but we can talk about ways of fixing it. Okay. The cell. Okay, now when I purposely put in the word review, because I know we've all seen this before. But this is lecture material. It will show up on the exam on the 30th. Okay. And it will also show up immediately on a practice test for you. We see a picture of a cell right out of a textbook. Pretty classical picture. No cell on Earth looks like that, but they still draw it because it's an idealized cell. Okay? And it has the components that we are looking for. You, if I wanted to do a matching type test, then this would be a perfect picture here without the labels, but the pointers would be there and letters of the alphabet that you would match up to the names. I'll tell you now that is not going to happen on lecture test number 1. That is not, you're not going to have anything to label there. Okay. Underneath, I have definitions of cellular organelles. Quite a few. Okay. So that you know where you can look to find them after I've gone through them up here. Okay. In the center, but let's move to the outside first and see right here. This is the plasma membrane, also known as the plasma lemma or the cell membrane. People tend to dismiss it like it's not important. It's so important. It allows material to come across and in, or to leave and exit. It allows some materials not to get across, and it starts in reverse to keep materials in so that they cannot get out. So the plasma lemma is very important. Okay. When the cell gets too big and the plasma lemma stretches way out here, your surface area to volume ratio changes. A very inefficient situation can exist when the cell gets too large, and then it would divide. In the center, you have the nucleus. The nucleus is double membraned. It's believed, but it's not proven, that a smaller cell invaded the larger cell. The larger cell would have been expected to digest the smaller cell, but it didn't. And so in coming in, it wrapped itself in a piece of the outer cell membrane, had a membrane of its own. So it's double membrane now. And they work in a symbiosis where both benefit. A dark spot within the nucleus is the nucleolus. You may have pronounced it nucleolus, but it's nucleolus. That dark spot in the human nucleus produces transfer RNA. Now, this is not a class in genetics. This is not a class in biochemistry. So I'm just mentioning that transfer RNA is produced here. And I'm not going to ask you ever what transfer RNA is going to be used for. Okay. I just don't want to leave a total blind spot. I'll tell you what it's going to be used for. It's going to be used to make proteins and enzymes inside of the cell. We need transfer RNA, we need messenger RNA, and we need ribosomal RNA. Well, the tRNA, transfer RNA, comes from the nucleolus. In the nucleoplasm, it looks like fine dotted areas. It's actually chromosomes that have unwound. Think of a rope, but not of hemp rope. Think of instead a rope that's made out of plastic fiber, type you see down at the harbor possibly. Okay, and it's all twisted up tight. Now with your strength, untwist it, twist it backwards. And all those fibers go everywhere. So what that rope represents is a chromosome. But when the chromosome is functioning, it can't be tightened up like that. It's got to be loose, and all the fibers or chromatids of the chromosome need to be exposed. And that allows them to be used as a template for the production of messenger RNA. I'm not going to ask you tRNA or messenger RNA. The nucleus is surrounded by all of the rest of the contents of the cell. This area between the nucleus and the cellular membrane is called the cytoplasm. I'm looking for the word cytoplasm, and I don't see it yet. Okay.
It's the bold at the very top.
Oh my God, it's everything, isn't it? Okay. It's the biggest word on the page. Here's cytoplasm. Well, I was moving down towards my definition.
They made it too obvious.
Okay. The cytoplasm, the area of the cell outside of the nuclear membrane. It contains fluid and other organelles. All of this stuff outside is the cytoplasm. Another word, though, that they did not point out, but I am, is the cytosol. The cytosol is the fluid that these cytoplasmic organelles are floating around in. The cytosol is the fluid portion. If you were having a pool party and nobody had arrived yet, but the pool was ready and full of water, that's and we can throw a beach ball in there and call it the nucleus. But the water is the cytosol. The water or fluid is not the cytoplasm. It's a part of the cytoplasm, along with the organelles. So when your guests arrive and they jump into the pool, now we could call that area cytoplasm or cytoplasmic. Chromatin. Inside of the nucleus, the chromosomes have spread out, become untwisted, if you will. And their chromatids, the small spring-like gene carrying structures, are all exposed and working. This is a cell in interphase. Interphase means non-dividing. In a dividing cell, which is breaking in half and reforming, the chromosomes will get destroyed unless they're protected. And then they wind back up again. And then under the microscope, we can see the typical chromosomes, the letter K, the letter X, everything you've seen on the crime shows. So the chromosomes can be very tight, but that's during division, and very loose when the cell is actually functioning. Interphase is the most active phase, most productive phase of any cell's life. It is absolutely never true, and I was taught that it was, so I was sort of disappointed later on. Interphase is not the resting phase, just to the opposite. It's the actual functioning phase of the cell between divisions. The nucleolus we already talked about, right here. The nuclear membrane, I told you, is a double membrane. It seems to possess pores, openings, and these openings spill the contents out into these structures here. These are connected tubules. Here are more connected tubules. This is called the rough endoplasmic reticulum, the darker area here. Rough endoplasmic reticulum. What makes it rough is the presence of the third type of RNA, that's ribosomal RNA, that latches on to these tubules and makes a beaded looking structure. Under the electron microscope, you can actually see this. This is rough endoplasmic reticulum. Now, with rough endoplasmic reticulum having ribosomes, transfer RNA coming from the nucleolus, and messenger RNA coming from the chromatin, and you're not going to have to repeat this. You have the ability to form proteins. You have a workbench, in fact, a place to actually build proteins. And that's on the rough endoplasmic reticulum. The rough endoplasmic reticulum is abbreviated sometimes RER. The main function of the rough endoplasmic reticulum, it's the portion of the endoplasmic reticulum believed responsible for protein synthesis. Okay. It's connected to these smooth pieces of tubule. They didn't draw as many of those. This is the smooth endoplasmic reticulum. And the smooth endoplasmic reticulum transports the proteins made by the rough endoplasmic reticulum, transports them towards this structure called the Golgi apparatus. There's not just one Golgi apparatus in a cell. There'll usually be several. Okay. Now think of it for just a second. Take a I don't know if the guys know this, so I was going to say a colander. Let's just take a bowl, kitchen bowl, large kitchen bowl, and look at it from the top down. Now you've got cooked spaghetti. Throw in a 2-3 inch layer of cooked spaghetti. Now put in the nucleus. That might be an orange, a plum, anything. Put that in there. Now cover the rest of the bowl with more spaghetti. Okay. And with the fork, reach down the sides and mix that spaghetti together. And what you've got is the nucleus embedded in a bowl full of tubules. These tubules don't just radiate out right and left like they're shown here. They come out towards us and behind us. Okay. The smooth endoplasmic reticulum, though, takes the proteins produced by the RER and transports them to the Golgi apparatus. The Golgi apparatus, also known as the Golgi body, packs the protein. It receives it, swells up, and there's no place for it to go except leave in small vesicles. I like to think of this as a space module, and these are small little individual spacecraft leaving. Okay. These little guys that are leaving have inside of them the enzymes produced way back at the rough endoplasmic reticulum. Many different types of enzymes, but many of them are what we call proteolytic. And they leave the Golgi apparatus, having gotten there, in these little structures called lysosomes. Here they're calling it a Golgi vesicle, but they enlarge, they take up water. When they enlarge enough, even the diagram people will call it a lysosome here and here. The lysosome contains proteolytic enzymes. Proteolytic enzymes break down proteins. Proteolytic enzymes are moving in these packets or lysosomes and attacking anything that's foreign inside the cell. Anything that is food-wise, calorie-wise, that's come into the cell. They will digest it and then spill it into the cytoplasm for all of the rest of the cell to use. The Golgi apparatus, area of lysosome formation and protein accumulation, which or packaging, which has to come first. Here's a vacuum. And where do we get the vacuum? The cell membrane can curve inward and suck up a vacuum. Sometimes the vacuole only contains fluid. Sometimes it contains solid material. Think of a golf ball. Golf ball has dimples on it. Okay, now I'm sure you've all seen a golf ball, even if it's only in a miniature golf course. The golf ball has dimples on it. Does anybody know how many dimples there are on a golf ball?
Nope.
I had a guy in the class once who knew exactly. 237.
Oh
And
my
I
goodness.
thought, well, come on, that's useless information. But he knew it, and golf was his thing. He didn't pass the class. I wonder why. But anyway, we have the dimples, and the cells are constantly sucking in through all of those dimples some fluid. And as they do, they make vacuoles. Well, would that explode the cell that's eating this fluid that fast? No, because the fluid, if it's not used, seeps back out. Okay. Sometimes, though, in sucking everything into those dimples, you catch some a piece of broken red blood cell. You might catch a bacterium. Okay. You might catch something else. That's good. And when you bring it in, you make a food vacuole that contains food. I have another drawing that will show you that. Okay. One more, and then we can go to those drawings. One more organelle, the mitochondrion. Here's a mitochondrion, looks like a kidney bean. Here, here. These things are able to divide themselves. When the cell divides, it's hopeful that about half of them go to one cell and half go to the other. If in dividing a cell leaves one side without any mitochondria, it will die. The mitochondrion is the site of cellular respiration. That's not breathing in or out, that's converting energy to different forms of useful energy, namely ATP and NADPH. The mitochondrion is absolutely necessary. Its double membrane is believed to have also penetrated and not been eaten. Okay, so has a double membrane just like the nucleus does. The food that's being spilled out of the vacuole, when the vacuole is attacked by a lysosome, attacks the vacuole, and the fluid, which is food, is released. Okay, there is some change in that fluid within the cytoplasm itself, but the final change to energy form is in the mitochondria. I will ask you, what is the main structure for respiration in a cell? And the answer's got to be mitochondria. Phagocytosis and pinocytosis. We refer to those dimples on the cell. When the dimples grab something like a piece of red blood cell and bring it in, surround it with part of the cell membrane, that's called phagocytosis. That's called cell eating. And the result of the phagocytosis is that the cell engulfs a potential food particle, surrounds it with a membrane, and forms a food vacuole. These food vacuoles are attacked by lysosomes and eventually digested. The same process may not miss something solid. I mean, you've all been fishing and bringing up the line and there's nothing on it. Still went through the activity. This is called pinocytosis, the same as phagocytosis, except that only fluid is captured. Vessels that form are called pinocytic vesicles. Pinocytic vesicles as opposed to food vacuoles when you bring the material in. This is the last of the drawing. In pinocytosis, at the cell membrane here, it sucks in fluid. Now, they've unfortunately drawn the fluid as something star-shaped. Fluid is drawn in, takes in fluid, and also solids. That's what they're showing, the stars. Solids can be salt, minerals. In phagocytosis, it pulls in a larger particle, in this case a bacterium. This is a pinocytic vesicle, fluids and solid, and this is a phagocytic vesicle, also known as a food vacuole. Okay, let me give you a break until 20 of 4. Okay, and you can think up some questions and ask me then. Okay. 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 Let's see. Okay, anybody come up with a question or concern? Did anybody find that email that had replied to it? You got it?
Sorry, that was my background noise, but I still wasn't able to find the email that you sent back after I sent an email regarding the glitch.
Okay. I may, did you look back at your Saddleback email?
Yes.
You looked at all your emails. Did you look at your spam folder?
Let me check that.
I was gonna say I haven't gotten it either.
It is in my spam folder.
It's there?
Yes.
Okay. Well, I'm not spam, so tell it to let me through.
All right.
Okay.
Thank you.
Okay. Harrison, what'd you say?
I haven't gotten it either, and I'm trying to look to see if it'll be in spam. I don't see it. I just see people's responses to it.
Okay. The strange thing is, think about it. I sent it out as a mass mail to every one of you with a address for you that I redid. Now, if somebody, everybody's getting that same email who gets it at all, and then somebody is replying to all. And so if they're replying to the same address for you that I used. They have to be. So for you to be able to see them, that the address is working, but where the email is ending up is the problem, I think. Okay, well, if you don't get, if you don't find that email, just send me a note and saying something like you're still looking, however. Okay, and I'll check. You know, I don't think it'd do me any good to look at my address for you, because if they're sending it back, reply to all, and it's getting to you, they're using the same address. But send me a note so that I can see what we can do. Okay.
Gotcha.
Anybody else with a question about what we're talking about? Good. Okay, we'll go back to sharing the screen. Okay. Uh, 9-2, that's today. Here's the bones and figure locations that we're going to use. Now I printed this out for myself. I have to too, because I can't see it on the screen otherwise. So I have it, and I'll call off the figure numbers for you if you don't have it already printed, okay? But it's a good one to have on hand. Looks like a lot of stuff, but some of it goes very, very fast. Okay, so let me back out of that. And here we go, upper appendicular skeleton. We're going to start with the scapula. Okay, the upper appendicular skeleton includes the scapula and the clavicle and each arm. This is looking at the scapula or shoulder blade from the anterior view. This is anatomical view. So this would set up against your back, and the posterior side is on the other side. It's roughly a triangle with a superior angle, straight down, the inferior angle, and over to the other side, the lateral angle, which I don't ask about because there's too many confusing things at that spot. Look for the superior border, which is really straight across here. Here's the superior. It's being pointed to like it's that one spot there, but it really extends all the way across, superior border. This is where your arm's going to go, so this must be where your back is. And this is the medial border. The medial border, this whole side, is also referred to as the vertebral border. You can use either, but hey, what you got coming is a multiple choice test. And I'm going to use medial in that case. Come down to the inferior angle. Now we go up underneath the arm. And this is the lateral border. The lateral border is sometimes called the axillary border. Axillary referring to the armpit. This whole thing, the whole bone, looks and feels in reality like a little shovel or trowel. Okay. It also looks like something you might have as an ashtray when you used to have ashtrays. Okay, but here's the scoop, and that's the body of the scapula. Two finger-like projections. This one comes out and looks like a bent or broken little finger. This is the coracoid process. You'll see where that comes into play in a moment. In the back, waiting for a better view, is the acromion or acromion process. And you'll see where it comes into play with the coracoid process in a moment. Now we have two views. Here's the view we just looked at on the left. Okay, that's the anatomical view. There's nothing labeled on the anterior view or anatomical view that wasn't labeled just a moment ago. When we look at the backside, so you go up and slap somebody on the back or high on the shoulder, this is the posterior view. The scapula has what we call a spine or scapular spine. You may not feel it with most people unless they're very thin people, because there are two pockets for muscles to rest. They do, and they come together very nicely and sort of make a smooth transition. Above the scapular spine is this trough. It looks like a trough anyway. If you took a cigar, you could lay it in there. Okay. If you took a piece of chalk, it would lie perfectly in there. If you took a marker board marker and lay it in there, it would be fitting perfectly. This is the supraspinous fossa. Supraspinous fossa. We'll come back to the spine itself and drop down to the other side. And this whole large, again, somewhat triangular area is the infraspinous fossa. Later on, you'll learn that the infraspinous fossa contains the infraspinatus muscle, and the upper one contains the supraspinatus muscle. At the end of the spine is the flared acromion. Now, the coracoid process that we can see on the left is almost hidden by the acromion. It's right here. The acromion and the coracoid process and one other structure to be named help hold in the arm. Okay, now we have all views. Here's our first view. Here's the view we just did. And now we're going to turn either one of them towards the center. No matter which one you turn, you end up with this. Here's the coracoid process. The clavicle sits on top of it. And there is a bond between the clavicle and the coracoid process. It's not a true joint, but very, very tight. The acromion process has ligaments extending from it. Not here, but in reality, it will have them and it will attach to the bone that fits in here. This is the head of the humerus that fits in here in this space called the glenoid cavity. Glenoid cavity. That's also called the glenoid fossa.
Charlie,
Yes,
did you say what sits right in there? The humerus?
the head of the humerus,
Okay.
your upper arm bone. The humerus is held in place mostly by the muscles. Okay, it does have ligaments to the acromion, the coracoid process, but most of what holds the arm in place are the muscles and the tendons that attach to it. This is showing the lateral border now, just to see that you got it in mind what the orientation is here. Here was the lateral border. When we turn this sideways, now the lateral border faces us. Here's a clavicle. We got two views of it. One end is fairly flat, but large. This end here is flat, but large. like you took a piece of or a rod of clay and here took your thumb and index finger and squished it. This is the acromion. This is the acromion from the other side. The other end is the sternal end. This meets the sternum at the clavicular notch that we did the other day. So now you begin to see the importance of reviewing the previous day's work. Sternal end here. Acromial end. It sits out there with the acromion. Let's see if I've got a good picture.
You said the sternal end meets what?
It meets the clavicular notch of the sternum. The top of the sternum, the manubrium, has a jugular notch and two clavicular notches for the two clavicles to fit in there. In the center of the clavicle is the body. That's always easy when they give us that. And then there's one bump just before you reach the acromion called the conoid tubercle. Conoid tubercle. That attaches to ligaments as well. It helps to stabilize the arm in its place. A couple of stray lines here where something was being asked and I took it out. This is the humerus. Actually, it should be a larger drawing if we wanted to compare it properly with the bones that we just looked at. This is the proximal end of the humerus. Up here, and here's the distal end. First, we have to figure out which is anatomical view, which is facing us. They both appear to be facing us, but they're not. Okay. Go down to the distal end, and one of them has this cavity, big cavity. Well, that's not facing us. That's at our back. That's when you crack your elbow or it pops. That synovial area right in there is making the noise. This is the front. This is the anterior view. The very top of the humerus that articulates with the glenoid cavity is the head. People think, oh, they'll never ask the head of a bone on the test because that's just too easy. We do ask some of those kind of questions. So here's the head. If you sort of look at this as a skull cap, right at the edge of the cap, where I am right now, that's the anatomical neck. Just underneath the skull cap, this is the anatomical neck of the bone. But a little farther down, where you can take your fingers and pretend your fingers are scissors and cut it, this is the surgical neck. We make that distinction because the surgical neck is where it usually breaks. The most commonly broken bone in the body is the clavicle. Little clavicle over here, in front of the scapula to the acromion. The clavicle is the most frequently broken bone. If I were to ask you, have you broken any bones? I'm sure I'd get a few yeses, and it probably wouldn't be the clavicle. The clavicle is broken mostly in older people, but accounts for the greatest number. Because when somebody trips or falls forward, they're going to put their arms instantly out in front of them. And the pressure or weight of that happening snaps the clavicle many times.
Does it happen in younger people as well? Or
Oh yeah, it can still happen. Yeah, it's
more
just
frequent?
okay. So we got the head, anatomical and surgical neck. Now let's come back to the anatomical view. This is facing you. There's a big bulge at the front. This is the lesser tubercle. It's going to be an attachment point for the ligaments and tendons that we mentioned just a moment ago in the rotator cuff. The rotator cuff is this bone rotating with the scapula. This is the lesser tubercle, but more lateral. Okay, the body's over here. Head pass by the lesser tubercle and go to this lateral tubercle. This is the greater tubercle. It's bigger still. Same function, attached. In between the two, the greater and lesser tubercles, is this groove. Fortunately, it's not an oral examination, or you would be asked to say interturbicular sulcus or interturbicular groove. I always ask my class to use their mind, or if they were in a lab, they use their model. But come down the interturbicular groove, about halfway down the bone, and it swells just slightly right here. That's the deltoid tuberosity, because the deltoid muscles, 3 of them, that make up your shoulder, the rounded part of your shoulder, they go down the side of your arm, halfway down the humerus to the deltoid tuberosity, and grab hold. That's where they have their insertion. Come down farther, and we find a ball, a cavity. We find 2 points at the distal end. Okay, I want to deal with the 2 points first. This is on the lateral side. This is on the medial side. Feel your own, the lower humerus before you go to your forearm. Feel on both sides. There's a bony projection, especially on the medial side. And then there's that bony point right at your elbow. You've seen it. You've seen it on other people. Okay. The one on the lateral side is the lateral epicondyle. And the one on the medial side, the larger one, is the medial epicondyle. On the side of the lateral epicondyle, now looking at the diagram, there's a ball. It's cartilage covered. It's called the capitulum. And extending with it across the other side, medial side, is the trochlea. These articulate with the radius and the ulna. You'll see that better in just a moment. So I'm going to leave a couple things here. Go to the posterior side, turn it around. We can see a bit of the deltoid tuberosity right here. It's unlabeled. Down at the distal end of the humerus, there's a cavity big enough to put your thumb in. This is the olecranon fossa. The olecranon fits in there. Well, what's the olecranon? The olecranon is a part of the ulna that we're just about to do. Okay. The olecranon fossa fits in there. And this is where you generate that popping sound, if you can do it, in your elbow. The trochlea extends to the rear here and is over here as well. We'll mention what this is in just a second. Go to a real bone. Okay, the yellow lines are meant for you to, at some point, give it a try. This bone, is it facing us or facing away? You got to look down here. Is it facing us or facing away?
Facing away.
No, but now everybody knows the answer. It's facing us. Okay, if we're facing us, facing away, you would have the fossa on this side. Here's the head. The star is on the lesser tubercle. The greater tubercle is over here. This is the intertrabecular sulcus, wasn't asked with the yellow. Here's the radial deltoid tuberosity. Now we come down, and on the lateral side, you find this ball, and that's the capitulum. The rest of this structure is the trochlea. If you know the game of chess and turn your head sideways to the left, you'll see a pawn in here. There's the head of the pawn, and there's the body of the piece. The capitulum, where the pointer is going to articulate with the radius. When you flex your forearm, that is, bring it up, like you're bringing up barbells towards your chin, bring it up. You can only go so far, and then you come to a stop, because you've got to stop right here. And this is the radial fossa. The head of the radius is going to fit into there, or actually a portion of the radius is going to fit into there and surround the structure of the capitulum.
Charlie,
Yes?
I don't see that one labeled on our humerus.
It isn't.
Okay.
It isn't labeled on that one.
Okay.
That's why I moved down here.
Okay.
Okay. Here's the trochlea. Here's the medial epicondyle. This one with the star is going to another small cavity And when you flex your arm, the ulna comes up and is stopped when it reaches the coronoid fossa. That's the coronoid fossa. I don't know why somebody named it coronoid fossa when it doesn't have much to do with the heart. So this is sort of like the coronoid condyle of the jaw. I remember it because in the jaw, because when you lower it, you go closer to the heart. And I remember this one because it's on the heart side. It's medial. Okay. If that helps you. Okay. This one's labeled. Okay, that's good. I'm glad I did that. Greater tubercle, intertrabecular sulcus, lesser tubercle, head, deltoid tuberosity. Here's the coronoid fossa that we just ended with. Opposite the radial fossa, the capitulum. Capit means head. So, and that's supposed to look like a head. Follow it along to the trochlea. This is the ulna. I'm going to start with this one. This is anatomical view. This is like a big mouth, a snake's mouth, or a hook. And it's coming from the back of the humerus. It's going to click into place at the back of the humerus. The top part, the largest projection at the top here, is the olecranon process. It fits in the olecranon fossa. And then you have the mouth. Easier to see over here. This is the trochlear notch. Trochlear notch. Why is it trochlear notch? Because it fits around the trochlea down here from the back and will curve up. If you put your cursor or eyes anywhere on the trochlear area, and then come around to this point, right at the end of the mouth. This is the coronoid process. In an X-ray, if you can find the coronoid process, then you've got it made. If you can't find the coronoid process, you're going to be guessing. So you need to find that coronoid process if you're evaluating an X-ray for a break or something. I like to put my thumb on the coronoid process and hold it with my fingers wrapped around here with the shaft. And then I take my thumb and I slip it off to one side or the other. And one side or the other will have this smooth radial notch. That's where the head of the radius is going to sit. I don't pretend to know in looking at an ulna if it's right or if it's left. I can figure it out, but it's just not worth the hassle. Okay, it's a lot easier to find the radial notch. The radius is always going to be lateral. The radius is always lateral. And the radius when we're talking about the upper extremities is always on the thumb side. Always on the thumb side.
Which one?
The radius, anything that says radial. The radial notch is on the thumb side if we were to follow it down to the hand. Okay. The radius itself in your forearm, you have two bones there. You probably today, right now, don't know which one's which. But if you feel the two bones in your forearm and follow the one out that goes to your thumb, that's the radius. The radius is always on the thumb side. Take the ulna, stand it straight up, and it rests on this little heel. That's called the styloid process. The styloid process of the radius. You don't need to know head of the radius. Styloid, like a pen. Here's the radius itself. Here's the head of the radius. This revolves around the capitulum. Remember, the capitulum was a ball, would fit right in there and continue over as trochlea. When you raise or flex your hand, it's going to go right around. There's the head. Here's the neck. And this is the radial tuberosity. On the rib, it was head, neck, tubercle. And for the radius, it's head, neck, radial tuberosity. You can't mix those two up. Come down on the radius. It's got a styloid process also. These two processes, one here and one for the ulna, sort of make a small cradle for the wrist. The ulnar notch. The ulna is going to fit into here. And you can't see it well. I never asked it because you really can't get a good view, even from the books. This was the radial notch. The head of the radius here fits here. And the bone radius goes down to here and fits into the ulnar I'm sorry, it's radial notch. It fits in right here, and that is the ulnar notch. Okay. I was going to be calling off figures, but I didn't do that for you. Sorry. That was all in the figure 8.3, 8.4. And now we're left with figure 8.6. The carpals, metacarpals, and phalanges. Okay. If you have your book, figure 8.6 might be pretty good. This is the back of the hand. Okay, so this is not anatomical view, because in anatomical view, you show your palms forward and you have your thumb lateral. So it would really be over here, but we can see that view next. Okay, everybody's familiar with the hand, or seems to be. First off, let's take out the digits. The digits are phalanges. Phalanges here, and singular is a phalanx. The thumb has two phalanges, the distal and the proximal. But all the others, the other four digits, have a distal phalanx. The distal phalanx has the nail on it. the middle phalanx, and the proximal phalanx. Same over here on the little finger, which is digit 5, distal, middle, and proximal phalanx. Now, that's 14 bones and 14 more on the other hand. We just took out 28 bones real quick. Okay. Well, not your fingers now, but farther back, the palm of your hand. You have 5 large, long bones, and they are number 1, metacarpal, metacarpal 2, metacarpal 3, 4, and 5. The thing that gives some people trouble, or they worry about it too much because it's actually quite easy, are the carpals. There are 8 carpals in each hand, and these make up the wrist. We'll get to those in just a second. Okay, we're looking at the palmar side right now. Tell because these are convex. Still, this is digit 1. This is digit 5. Okay. Let's follow back on digit 1, the thumb. Okay. This is the distal phalanx, middle, the proximal phalanx. Okay, there's only 2. And then we have metacarpal 1. And then down here, one bone of the carpals seems to articulate with metacarpal 1. It has its own. Now they've identified it as T2. I wouldn't have, but it doesn't matter. It's the same thing. This is the trapezium. Trapezium here. Move over to metacarpal 2. It hugs 1 carpal. They've identified it as T3, but it's the trapezoid. Trapezium, trapezoid. Easy to mix up. They're in alphabetical order if you think about it. Trapezium, trapezoid. Under metacarpal 3, 1 carpal, and that one's the capitate, because it does actually look a bit like a rock sculpture of a head. Capitate. Under metacarpal 4 and 5, these 2 share 1 carpal. It's labeled H for hammy. And it has a projection coming out towards us right here. Hard to see. That's the hammy. We have taken out 4: trapezium, trapezoid, capitate, and hammy. And these 4 all articulate with the metacarpals. The final 4 do not articulate with the metacarpals. I'm on the last one as well. So let's try those. Come back to the thumb, metacarpal 1, trapezium. Now, we're not going to go to trapezoid. We're going to go straight ahead. This is the scaphoid, also known as the navicular. They've got it properly labeled scaphoid. It's like a little boat, an ark, a basket that goes underneath the capitate, and then you have the lunate. The lunate is called so because it really looks like a moon, but you've got to take it apart. You've got to take it completely apart. Or just know it comes after scaphoid. After the lunate, you have the triangular because of its shape, also known as the triquetral, also known as the triquetrum. It's got several names. In this rendering here, it's T1, triquetral. And there's one left, the little one here, P. That's the pisiform. It is as small as a pea. That's the pisiform. It usually sets up close to the point on the hamate, so that the arm on the little pinky side, if you feel your own wrist, where the wrist and palm come together, there's a bump over there, usually. Not everybody has that, but it's these two in conjunction. I'm coming back to this one where it only says carpals. Well, I'm going to start over here at number 1, articulates with the trapezium. Number 2, articulates with the trapezoid. Metacarpal 3 articulates with the capitate. 4 and 5 with the hamate. Let's go underneath the trapezium and trapezoid to this little boat, the scaphoid or navicular. Here's the lunate. This one is the triquetral. And we can't see the pisiform because the pisiform's on the other side. That little round ball sits up right about here. But we can certainly see the others. Okay. I can't believe it. Everybody's still here. Okay. Any questions? Yes.
We have to memorize the carbons.
The what?
The carbons.
Carpals.
Carpals?
Yeah.
Yes. Yes, you do.
Okay.
Yeah. You know, wait till we get farther in the course and you're going to realize that you may have been worrying for not, a little bit too much. Yes, you have to memorize it, but until you know you can do this kind of memorization, yeah, you're going to be a little edgy, but you can do it. You can do it. And some people will put together a little puzzle or a slogan or a saying. Me, I just like to memorize. Yes, you do have to know those structures. All the structures that were on the pages for the skull, upper and lower appendicular skeleton, and lower is coming on Tuesday, and the vertebra. Those pages that say the figure numbers, okay? Those are all fair game.
Charlie,
Yes.
do we also need to know articulations, what they articulate with?
No.
Okay.
Okay. I'm trying to see if I want to slow down for a second. I mean, there's many times I've told you what something articulates with, but me telling you and me showing you and having it in writing, those are different things.
Okay.
So don't expect any questions like that. Okay. Remember, please, 22, maybe some more now. I haven't checked email, of course. 22 people sent me a reply to yesterday's glitch. You'll know the email. It says glitch in it, and If you didn't get that one, take a look in the spam folder, other places. If you still didn't get it, then write me that you don't have it. Don't know how quickly I can repair that, but we got to get it repaired. Got to figure out what went wrong. Okay, then what I'm going to do is stay here, and you can exit, and then stay if you want to ask a question. If it ends up being a confidential type question, we can go elsewhere. Okay,
Thanks, Charlie.
take it easy.
Thank you.
Thank you, Charlie.
Thank you.
Thank you.
Have a good weekend. Thank you.
Bye bye.
Thanks, Charlie.
I have a question.
Yeah.
For the lecture notes or for the lecture note test, can we use our outlines for it?
No,
Okay, so the lecture notes also just all memorization too.
everything.
Okay, and then before the two tests, will we have like a discussion about what's going to be on it?
Yes.
Okay, got it.
Oh, we will. And, I'll have an open discussion group,
Okay.
on Zoom in the other class for those that are signed up, and the other ones that can easily ask questions elsewhere, and you can too. But I'm not just going to let you hang there. I'll keep pushing too to be sure that you keep up.
Charlie, do you know when you'll do that discussion? Is it like a couple days before the test or the night before?
No, I
week
don't know.
after?
I don't know just yet.
Okay.
Okay, and the reason I don't, I've actually changed test dates sometimes when I realize it's not to the benefit of the class.
Okay.
Yeah. And if I do, I'm not going to change your test date. Don't worry. When I have changed the test date, I've always offered the people that don't want to change. I offer them then, okay, I will give you the test at the regular time.
Yeah.
And I do that, but they always back out. They always back out because they finally realize that the change was for the better.
Right, right.
Okay.
Thank you so much.
Bye-bye.
Bye.
Thank you.
Bye.
Charlie, I'm confused about the where do we stop on chapter 6? So in SpongeBob, yeah, chapter 6.
Anybody have the book out right now?
Yeah, I have it.
Oh, you have yours.
I have it.
I've got mine here too, but in an awkward spot.
Okay, I have mine
You
too.
want to know where I said to stop?
Yeah.
Okay.
It was at the bone remodeling. It was like 6.2 bone remodeling.
Okay, before bone remodeling, right?
That's it. Yeah.
Yeah, right before, like when you
Right.
bone remodeling, stop.
Yeah.
Yeah.
And postnatal growth of endochondral bones with us. The before bone remodeling.
The
growth
bone development and growth?
Uh-huh.
Yes.
Yes.
Okay. Okay. Perfect. Okay, thank you.
Yeah.
Bye.
Bye-bye.